All right, so let's continue our discussion here about the movement of heat. In the previous introduction video, I talked to you about the general movement of heat going from high concentration of heat over to low concentration of heat. Okay. Now, we're not going to get into the real specifics in this particular video about how this really works, and we're not going to talk about energy diagrams or anything like that. But, or what we do want to discuss is going to be, we definitely do want to discuss the concept of how the heat is actually occurring. And we discussed this briefly in a previous video. And so remember here, when we talked about heat previously, heat was proportional to kinetic energy. And so as you increased, so if heat rises here, proportionally the kinetic energy will also increase. And so remember how this occurred was, so let's say that we had a container, and put a container here. Let's pretend that we also had a flame. And so the flame then would allow heat to be applied. And on the inside of the container, let's just say that we have a couple of these particles. Let's put them in blue. And so initially, the kinetic energy of these particles, if we say that the temperature is very low, the kinetic energy is really low. And so over time, the flame then would transfer or accelerate the particles immediately above the flame, causing their kinetic energy to increase, and that would cause an impact on the container wall here, which would then increase in temperature. And then all these particles down here that are actually in there would come in contact with the container wall. So let's take a look at that one in particular here. And so it would then cause a momentary contact with the wall, which is now at a higher temperature. Since we're going from high to low, some of that temperature then will be transferred over to the molecule or the particle, causing it to vibrate at a slightly higher frequency relative to the others in the mix. That then would cause it to increase its overall kinetic energy. Remember, the kinetic energy was equal to 1/2 the mass times the velocity squared. And so here, what we learned was that lighter particles then would be able to travel a lot faster because it would require a little bit of temperature change, or it would absorb a little bit amount of energy and would still cause it to move rather quickly, whereas larger substances or samples would require a tremendously more amount of energy, thermal energy, in order for them to actually increase their kinetic energy overall. And so this process here would happen for all of the particles. And so this particular one here, as it's going through, would then be traveling here, and it would collide. Let's change that to yellow. And it would collide here with the wall, and it would collide there, and it will continue going in various different angles here. And this is just the path of one particular particle, but imagine all of these particles being accelerated together over the whole. Now, in the next couple of videos, we'll explore how this really works in terms of the average kinetic energy that you experience among the particles, because clearly not all of them are going to be able to transfer or absorb that energy quite quickly and at the same frequency, because not all of the particles are directly in contact with the container. So those particles directly in contact with the container are then going to be able to absorb that heat rather quickly compared to those molecules or particles that are further away from the container. Either way, though, what we're dealing with here is going to be this heat as a substance of sorts. If you think about it that way, then you can actually kind of put the little discussion around concentration of heat as if it were a reactant of some sort, some kind of solution, if you will. And if we look at it that way, then we now know that if we apply a tremendous amount of heat in a certain given area, then that particular area then would have the highest concentration of heat. And in this particular section here, if I kind of do this in, let's put this in red, we can see that the highest concentration of area would be in this region right here. Right here. I don't know if you can see that, so let me put this in blue. But it'll be right here in this area right here. This is the highest concentration of heat that is being applied to this particular solution or this particular sample. Now, if we look at the area over here, that would have a lower temperature than the area down here, and vice versa. if you were to have a slightly different location, like on this side, this temperature here would be lower than the one down here. And so all of this is going to be proximity, or how proximal you are to the source of heat, because that is going to be the highest concentration of application of heat overall. And so we'll continue to explore this section here in the next section. So if you haven't already done so, go ahead and click subscribe, keep watching and learning, and we'll see you in the next one.